Hello my friends, welcome to AbishaTube. In this short video tutorial, we are going to study about power in AC circuit using C++ programming. The outlines are active power, reactive power, apparent power, power triangle, and power factor. So let's get started. So what is an active power? Active power is the actual amount of power being used or dissipated in a circuit. The amount of power that will be dissipated by the load is termed as active power. Is measured in watts and is symbolized by the letter P. So the other name for active power is true power or real power. So active power or real power consumed by circuit is converted into useful work. Mathematically, active power is given by the product of V voltage, I and cos phi, where P is true power or active power, V is the RMS voltage, I is the RMS current, phi is the angle between voltage and current. So in active power, power is delivered from the source to the load, that is, it is unidirectional. When it comes to the features of active power is always positive and doesn't change its direction. So always the power flows from the source to the load. Active power is measured using wattmeter and it produces heat and light as well as mechanical power. And the next type of power is reactive power. It's a term also used for imaginary power or wattless power. The power will not be dissipated in the form of heat and light in the case of reactive power. So it is a form of energy stored and released by the reactive components, particularly inductive load as well as capacitive load within a current flow through the electric circuit. The power will flow in both directions, from the source to the load and from load to the source. The example for reactive loads are inductive loads, inductors, inductance, and capacitive load, capacitors or capacitance. So the reactive power is designated by the letter Q and is given by the product of Vi and psi phi, where Q is reactive power, V is RMS voltage, I is RMS current, and phi is angle between voltage and current. So the power is not useful to the circuit. Also, this reactive power creates inefficiencies and loss of energy by increasing apparent power. What are the features of reactive power? It changes direction periodically and is positive as well as negative. Whereas when considered active power, it is unidirectional and it is positive only. And it is denoted by letter Q. The units to measure this reactive power are volt ampere reactive or kilovolt ampere reactive or mega volt ampere reactive. It's measured using volt ampere reactive meter. So transformer and inductor motors use reactive power to produce magnetic field. So it doesn't contribute any work. The next one is apparent power. Is a sum of active power and reactive power. The unit for measuring apparent power is kilovolt ampere. And the apparent power is the product of RMS values of voltage and current. Vrms multiplied by Irms. Also, the apparent power is the sum of true power and reactive power, where S is apparent power, P is true power, and next to this one, let's see the power triangle. This one is true power in the real axis, and this one is reactive power in imaginary axis. The sum of these two powers is apparent power, which is measured in volt ampere. And this angle is known as the power angle. Cos phi is the ratio between true power and apparent power. So power factor, it is defined as cos phi, which is equal to active power divided by apparent power. The aim of this program is to compute AC power delivered to the load, that is to calculate 1. Real power, 2. Reactive power, 3. Apparent power, and power factor. Include airstream, include IOMANIP, include CMATs using namespace standard, and we define pi as the cos inverse of -1, a cos -1, cons double pi, a cos of -1. Step 1, variable declaration. W AC power supplied or AC power delivered to the load. Z load impedance in ohm. Angle or load impedance. I current flow through the circuit. Rad angle which is converted radian form. P real power. R reactive power measured in volt ampere reactive. A apparent power which is measured in volt ampere. P power factor. So the next step is prompt and input the value of Vz and the angle. So enter the AC power supply voltage, so in V, enter the impedance, load impedance, Z, enter the angle in degree, angle. Step 3, calculate the intermediate values needed. Rad angle is equal to angle multiplied by pi divided by 180, and the current is equal to I is equal to V divided by Z. Step 4, compute real power, apparent power, and power factor. P is equal to V times I times cos of rad angle. So this is real power computation. R is equal to V times I times cos of rad angle. Thus reactive power computation. A is equal to V times I, apparent power computation. And the power factor PF is equal to cos of rad angle. Set up for floating point format for output. So that is output formatting. Cout fixed set precision. Let's set the precision digit into 3. Let's see the results. Cout power supplied to a load results. AC voltage supplied, set width 8 V, so it will display supply voltage. Load impedance of Z at an angle in degrees. Yields the power factor. So real power supplied is P, reactive power supplied is R in volt ampere reactive. Apparent power supplied is A volt ampere, and the power factor is PF.